This topic is titled Quadratic Equations, the Factoring Method. In this module, we are turning our interest once again to solving equations. In particular, we are studying quadratic equations. Simply put, quadratic equations are equations that contain a squared variable. That is, equations of the degree 2. Here are some quadratic equations. X squared plus 5x plus 6 equals 0. 3x squared plus x equals 0. X squared equals 25. In each of these examples, notice that the highest degree or the highest power on the variable is 2. Hence, they're called quadratic equations. Formally defined, a quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. Now, understanding the type of equation being solved is the first step in successfully solving that equation. So please make a special point to understand the difference between quadratic equations and linear equations. Recall, linear equations are equations that have a variable to the first power only. The following is an example of a linear equation. 6x minus 5 times the quantity x plus 1 equals 3x plus 7. It's a linear equation because the highest power on any variable is the degree 1. Notice it's just x, or x to the first power, that appears in this equation. That's what makes this linear. We know how to solve linear equations. Let's quickly recall by solving this equation. What's the first thing we do? Well, we simplify both sides. On the left side, that means we have to first use the distributive property. We need to distribute the negative 5 through to the x and the negative 5 through to the 1. Doing so gives us the following. 6x minus 5x minus 5 equals 3x plus 7. Again, we continue simplifying each side of the equation, and on the left side, we can combine like terms. So we put together the 6x and the minus 5x. This gives us x minus 5 equals 3x plus 7. Our left side is simplified. Our right side is simplified as far as possible. We now proceed with the addition and subtraction properties of equality, where we add and subtract to get like terms together. We first move our variable term, 3x, from the right side to the left side, and we do that by subtracting 3x from both sides, as so. That gives us negative 2x minus 5 equals 7. Continuing to use reverse operations to isolate x, we need to put the constants together. We do this by adding 5 to each side. That gives us negative 2x equals 12. We complete our process by dividing both sides of the equation by negative 2. And that gives us x equals negative 6. We should be pretty good at solving linear equations by now. Well, now we're going to turn our attention to quadratic equations. Remember, quadratic equations have a variable to the second power and no variable higher. Namely, quadratic equations are equations of the second degree. Like the equation x squared plus 5x plus 6 equals 0. The highest power is 2. Now, the strategy used to solve linear equations, namely reverse operations to isolate the variable, cannot always be used to solve quadratic equations. For example, when there's an x squared and an x being added in a quadratic equation, you will not be able to simply isolate the x using reverse operations. Watch. See, if we tried to use reverse operations to isolate x in the equation x squared plus 5x plus 6 equals 0, we would try to get x by itself. This would mean we'd have to move the x squared and the 6 term to the right side. But doing so, we have x by itself, or we could get x by itself, but notice we still have an x term over here. So reverse operations is not the process that we will use to solve quadratic equations. That previous example makes it clear that we need to develop a new strategy to solve quadratic equations. In fact, there are 4 methods to solve quadratic equations that we are going to discuss in this module. In this particular topic, we focus on the first method, that being the factoring method. The key to the factoring method is an important principle. It's called the zero product principle. Suppose that A and B represent real numbers. Then the zero product principle states the following. If A times B equals 0, then A equals 0, or B equals 0, or both A and B are 0. Let me try and explain this property a little farther. Suppose we have 2 numbers that we will multiply together to give us 0. These 2 boxes will hold those 2 numbers. The question is, what number can I put here and here so that when I multiply them, it gives me something that's equal to 0? Well, let's suppose this first object is anything. Let's just say the number 2. What would I be forced to put in here so that 2 times that quantity equals 0? Well, the only thing that could go here would have to be a 0, right? 2 times 0 gives us 0. Let's look at another case. Suppose we have any number over here. Let's just say 8 or negative 8. It doesn't matter. But we have to multiply 8 by something so that we get 0. Again, in this case, we have to have a 0 in this box because the only thing multiplied by a number that gives us 0 is 0. That's the idea behind the zero product principle. When you have a product, and I will stress, a product of 2 objects, in order for that product to equal 0, then either the first one is 0, or the second one is 0, or they're both 0. Otherwise, the product would not equal 0. Now, how does this apply to our quadratic equations and the factoring method? Well, recall, when we factor polynomials, we are writing those polynomials as products. And that's how it's all going to tie together. Let's take a look. Let's revisit the quadratic equation from our previous example. That is, let's solve x squared plus 5x plus 6 equals 0. This time, instead of trying to isolate x, let's use the zero product principle to solve the equation. Now, in order to apply the zero product principle, we need 2 things. One side of the equation has to be 0, and there must be a product on the other side of the equation. Once our equation is set up in that form, then we can apply the zero product principle, which says that if A times B equals 0, then A is 0 or B is 0. Now, in particular, we are solving the equation x squared plus 5x plus 6 equals 0. Notice in our equation, we already have one side equal to 0. However, unfortunately, we don't yet have a product on the other side. But no worries, we can factor the polynomial on the left side and therefore introduce a product. Observe, x squared plus 5x plus 6 factors as the quantity x plus 2 times the quantity x plus 3. Let's use this factored form to solve the equation. X squared plus 5x plus 6 equals 0. The right side has a 0. The left side we factor as x plus 2 times x plus 3 equals 0. We now have a product on the left side, and we can apply the zero product principle, which says that if you have a product of 2 objects and it's equal to 0, then the first object is equal to 0, the first factor is equal to 0, or the second factor is equal to 0. In this case, x plus 2 is 0, or x plus 3 is 0. x plus 2 is 0 when x is negative 2, which you can achieve by subtracting 2 from both sides. Similarly, x plus 3 is 0 when x is negative 3. In other words, when you subtract 3 from both sides to isolate x. Let's check. If we take negative 2 and substitute it into our equation right here, we'd have negative 2 plus 2. And so this factor right here is 0, and 0 times anything is 0. Likewise, if we took negative 3 and substituted it back into this quantity, negative 3 plus 3 is also 0, so 0 times anything would give us 0 again. That means the solution set for this equation is simply the set of numbers negative 2 and negative 3.